now we want to talk in more detail about what antimatter is. So in our previous segment, we talked about particles such as mesons were composed of two quarks. So one of the quarks was a matter quark, and then the other quark was antimatter quark. So for every quark, there is going to be an antiparticle that goes with it. So antimatter is going to be the same as ordinary matter, so that means it's going to have the same mass, but it's going to have opposite spin, and it's also going to have opposite electrical charge. So for example, a lepton that we talked about was the electron. And so an electron has a negative charge, and then it's spinning in a certain direction. So its antiparticle is going to be called the positron. And a positron would be the same mass. So if you were to take a positron and put it on a scale, it would weigh the same amount as the electron. But the difference is that the positron has a positive charge, and it would be spinning backwards compared to the regular electron. So this would be matter, and then this would be antimatter. In the same way, you could have the opposite of an up quark would be given by that, and the antimatter one that goes with the down quark, you just put a bar over the top of it. So what do you think you would get if you took a anti-up, an anti-up, and an anti-down, and you put them together? What particle would you get? Well, it turns out that you would get a proton, but that proton would have a negative charge that would go with it. So this would be the antiproton that goes with the regular proton. And you could do the same thing over here, and so you could, in theory, you could have an anti-neutron, but since the neutron is electrically neutral, there's not much difference between an ordinary neutron and an anti-neutron, except for the spin of it. Okay, so that's what we mean by antimatter. Now, what happens when matter meets antimatter? So if you have an antiproton and a regular proton come together, what's going to happen to them? They're going to turn into pure energy. And this is given by Einstein's famous equation, E equals mc squared, where E is the energy that would be released, m is the total mass. So it would be the mass of the proton in kilograms plus the mass of the antiproton in kilograms. And so you add those two numbers together and then multiply it by the speed of light squared, and then that would be the energy that would be released in a matter-antimatter explosion. You could have a up quark and an anti-up quark, and they would come together and they could explode, but it would be a smaller explosion because the mass of these particles is going to be less than the mass of the proton. Okay. So we have just shown that when matter and antimatter go together, they make energy. So could we take energy and turn it into matter and antimatter? And the answer is yes. So in our previous lesson, we talked about virtual space and how it was a sea of infinite energy that surrounds us and permeates us, and that energy can spontaneously turn into matter and antimatter for very, very short periods of time, so that these particles of matter and antimatter can pop into our existence for a short period of time, then they go back together again, and they disappear, and they go back into virtual space. So this is also called the energy vacuum. And it is constantly fluctuating, meaning that in one spot, all of a sudden these particles appear and then they disappear, but the particles reappear and disappear somewhere else. So it's constantly fluctuating. And so what I'd like for you to do is to watch this little video here, Empty Space is Not Empty, on YouTube, to explain how these particles of matter and antimatter are appearing and then disappearing. Okay, did you watch it? All right, hope you did, because did you notice how those fluctuations are making these bubbles? Okay, and then do you recall that when we talked about the formation of the universe, and at the very largest scales, the universe consists of bubbles. And then in the cracks where the bubbles are located at is where the clusters of galaxies are located. So if you watch this video, you will notice how that as these things appear and then disappear, it's kind of like making bubbles. And so we think that if you take this process and then as one of these bubbles is forming, the entire universe expands suddenly, then that explains how the universe gets this bubbly structure associated with it. All right, now things are going to get a little bit more wild. And so let's take a break, and when we come back, we're going to talk about the Nucleon Hotel.